All right, so for this problem here, I'm doing an electrolysis problem, and I just wanted to use the information given to us from the lab because I think a lot of you guys kind of had questions on how this works out. And if you guys remember, we took some DI water, you threw in a pinch of sodium sulfate, you added in universal indicator, and we used our little battery to add some energy to the reaction. And I wanted to review how to set up a problem like this. And I told you guys this is kind of a very good problem to know how to do because it's been seen on past AP questions. So this little chart that you guys have here would be an example of the information given to you on the test. So you guys could see here that there are reduction potentials. The equations are given out, and keep in mind that they're all being reduced. So the electrons are over on the left side. The cell potentials are given to you guys here, positive versus negative. And I just wanted to recap here as well the cathode and the anode. So we've been already talking a lot about this, but at the cathode, or the cathode is where reduction takes place, red cat. And then the anode is where oxidation takes place, inox. So reduction reactions, remember, are when you gain electrons, and oxidation reactions are where you lose electrons. Okay. Now, we know that in our solution of sodium sulfate, it dissolved. So we have ions that are now sitting in the water. You have Na+, and you also have sulfate ions, just like this. And remember how in class today, I told you guys a little trick to know which of these ions are going to go to what. The cat ion here, the Na+, is going to go to the cathode. The anion, the SO4 -2, is going to go to the anode. So the Na+ is going to come here, and then the sulfate we're going to be writing in later for the anode reaction. And all you guys have to do at this point is find the equation right here. It's reduction, so I'm just going to write it exactly as is. And our cell potential here is -2.714. Okay. And keep in mind too that it's not just the sodium and sulfate automatically that are reacting at the cathode and the anode. There is water inside of the reaction as well, which has to be included. And there are two different water equations that you could pick from. So remember I told you guys in class that you need to be able to recognize which one is which, okay? And student helpfully told us this one. If you guys see oxygen gas as one of the products or reactants inside the water equation, this is the one that's actually going to take place at the anode because oxidation, oxygen right there. So I'm going to actually save that one for later. The other water equation is the one that's going to be reduced, and that's going to take place at the cathode. So I'm going to go ahead and copy down the second water equation, or I'm sorry, the third one that you guys see here. Okay, so between these two reactions that you see written out, I'm going to compare the cell potentials here. This one's -2.7, this one is -0.8 to 8. So this guy here tells me that the water is the one that is most likely going to react at the cathode. And how do you know this? Because -8 or -0.828 is a much larger number than -2.714. So this is a more likely reaction to actually happen at the cathode. Now, the sodium ion, we could assume, is something that thus did not react at the cathode. Okay? And if you guys remember the setup for the lab, we used universal indicator inside the Petri dish because the hydroxide ions that are being formed here, it's going to come up as basic. So if you guys saw like a purplish color forming on one end of your pencil, it was because of the hydroxide ions that were being formed. Okay, now let's take a look at the anode section. So at the anode section, we said that your anions are going to come here, and we said cations go here. So the anion that we're looking at is a sulfate. So if you guys take a look at the second equation given to you in your little chart, This is our sulfate. But because it's oxidation, we know that we need to take this equation and actually flip it, because these guys all here are reduction equations. So I'm going to go ahead and do that. We have our, so we're going to reverse the equation. We have SO2 plus 2H2O produces sulfate plus 4 hydrogens plus 2 electrons. And then the cell potential, instead of being positive 0.20, since we switched, or not switched, since we flipped the equation, it's going to become negative 0.20. Okay, so that's how we got that. And then we also know that water is something could definitely react with the anode as well. And again, picking from the two water equations that are given to us, it's oxidation, so I know that I'm going to go for the equation that forms oxygen. And same deal as before, you have to take your equation and flip it because it's oxidation, not reduction. So let's rewrite this first equation that you have there. It's 2H2O, that could form oxygen gas plus 4 hydrogen ions plus 4 electrons, and then you end up with 1.23. And notice the charge here, it's positive, so we do know that that has to be turned into a negative sign. Now, for this reaction over here, we're going to do the same thing as before, compare the E values, okay? And whichever number is going to be a bigger number is the one where it's more likely. So negative 0.2 versus negative 1.23. This guy right here is going to be the more favorable or more likely reaction that's going to occur at the anode. Okay, and we can go ahead and kind of just cross off this one, because although we know it's possible, we know that this didn't really occur. And that's it. If you guys are taking a look, and if the problem asked you, well, what element was getting reduced at the cathode, you could say it was water and it produced hydroxide ions. And then if you're taking a look at the anode, you could say that it was the sulfate ions that were going ahead and reacting over here. And yeah, and then you would be able to get an idea for what is getting oxidized and what actually is getting reduced here based off of these numbers. And that's pretty much it. If you wanted to figure out, let's just take it one step further. If you guys wanted to take a look at the overall reaction for what's happening, just remember all you have to do is add these two up, and our 2 electrons are going to cancel out on each side, so you end up with 2H2O plus SO2 plus 2H2O. We have H2 plus SO4 negative 2 plus 4 H's plus 2 OH's, and you would have to kind of simplify everything out. The 2 OH's here are going to react with 2 of the hydrogens over there to form 2 waters. This would go down in number to 2. Then the 2 waters here are going to cancel out because I see 2 waters over there. And if you leave everything behind, that would be your overall reaction. And then what's going on overall in terms of voltage, you would just take these 2 guys here, and all you would have to do is add them up to get what the total value is going to be. So we're going to get 1.028 negative volts for the reaction. And that's it. This is pretty much just summing up the electrolysis reaction here for sodium sulfate and water.